The moon does not care about you. It never has. And yet, on certain nights, nights like tonight, it draws closer. Close enough that you might feel something primal stirring in your chest. Close enough that ancient peoples fell to their knees in terror. Close enough that you start to wonder if perhaps, just perhaps, the cosmos is trying to tell us something we're not ready to hear. They call it a Super Beaver Moon. The name sounds almost comical, doesn't it? Almost quaint. A remnant of colonial America when November's full moon signaled the last chance to set beaver traps before winter's frozen grip made survival the only thing that mattered. But strip away the folksy label, peel back the layers of cultural naming conventions, and you're left with something far more unsettling. A celestial body. Roughly 81 billion trillion pounds of ancient rock, hurtling through the void at 2,288 miles per hour, swinging closer to Earth than it has in decades. And here's what they don't tell you in the astronomy textbooks. What gets glossed over in the friendly science articles with their cheerful graphics and reassuring tones. The moon's orbit is not stable. It never has been. It's a slow-motion dance with chaos, and we're all partners, whether we chose to be or not. You've been taught to think of the night sky as orderly, predictable, a cosmic clockwork that runs on mathematical precision, where every planet knows its place, and every moon follows its prescribed path, with the reliability of a German train schedule. It's a comforting lie, the kind of lie that lets you sleep at night. The kind of lie that makes you think the universe operates according to rules that favor your continued existence. But what if I told you that this Super Beaver Moon, this astronomical event that happens with seeming regularity every year or so, what if it's not regular at all? What if these moments when the moon draws near are not simply gravitational coincidences, but warnings encoded in orbital mechanics? What if the cosmos has been screaming at us in a language we've refused to learn? Consider this. The moon is receding from Earth. Right now, as you process these words, our celestial companion is drifting away at roughly 1.5 inches per year. It's been doing this for billions of years, ever since a Mars-sized protoplanet. Scientists named it Theia, after the Greek Titan slammed into the infant Earth with such catastrophic violence that it vaporized entire continents and ejected enough molten debris to form the moon itself. That collision happened 4.5 billion years ago, and we're still living in its aftermath. The moon was born from cosmic violence, and it's been trying to escape ever since. Slowly, inexorably, like a child growing up and moving away from home. Except this child controls your oceans, influences your weather patterns, and quite possibly regulates the very biological rhythms that govern life on this planet. And it's leaving. But here's the paradox that should keep you awake tonight. Even as the moon retreats, its orbit remains elliptical, not circular. This means that during certain points in its monthly journey, it swings dramatically closer to Earth, sometimes more than 30,000 miles closer than its farthest point. These are the moments we call supermoons, when the moon appears up to 14% larger and 30% brighter than usual. But size and brightness aren't what should concern you. It's the gravitational influence. It's the tidal forces. It's the subtle but measurable ways that our planet deforms under the moon's gravitational embrace during these close approaches. The Earth is not a rigid sphere. You think of the ground beneath your feet as solid, immovable, constant. But during a supermoon, the entire planet, land, ocean, atmosphere, everything, stretches toward the moon like a lover reaching across an impossible distance. The solid earth beneath major cities rises and falls by as much as 12 inches. 12 inches! The ground you stand on breathes with the moon's nearness, and you never even notice. The oceans, of course, respond more dramatically. Tides surge higher, coastal regions flood, and in rare cases, when a supermoon aligns with particular atmospheric conditions, with storm systems and geological stresses, things can go catastrophically wrong. The 2011 tsunami that devastated Japan? It happened within days of a supermoon. The 2004 Indian Ocean tsunami that killed more than 230,000 people? 2 weeks before a full moon, when tidal forces were already elevated. Coincidence? Perhaps. Or perhaps the moon has been whispering warnings that we've interpreted as random tragedy. But let's go deeper. Let's talk about what science rarely discusses in polite company. The possibility that celestial events are not merely mechanical phenomena, but informational ones. That the universe itself might be conscious, aware, communicating through the only language available to cosmic entities: gravity, light, and time. Consider the precise mathematical relationship between the moon and the sun as seen from Earth. The moon is approximately 400 times smaller than the sun, and it happens to be, on average, 400 times closer to Earth. This means that during a total solar eclipse, the moon fits almost perfectly over the sun's disk, a cosmic alignment so precise that it strains the boundaries of coincidence. Astronomers will tell you this is chance, that in a universe with billions of moons orbiting billions of planets, some will inevitably create perfect eclipses. But Earth is the only place in our solar system where this occurs. The only place where intelligent observers can witness the sun's corona revealed in perfect totality, where ancient civilizations were shocked into scientific awakening by the sight of day turning to night. Is this really random? Or is it a message we've been too intellectually proud to acknowledge? The Super Beaver Moon arrives in November, a month that carries its own weight of symbolism and history. November is when nature dies, when trees shed their leaves in preparation for winter's annihilation, when daylight contracts and darkness expands its territory hour by hour. Ancient cultures understood November as a threshold month, a time when the boundary between the living and the dead grew thin, when spirits could cross between worlds, when the cosmic order shifted in fundamental ways. The Celts marked it with Samhain, the Aztecs with the Festival of the Dead. Modern culture has diluted these traditions into Halloween candy and Thanksgiving turkey, but the underlying anxiety remains. November is when we feel most acutely that something is ending. That winter, both literal and metaphorical, is coming. And into this month of transition and dread, the moon arrives closer than it has any right to be, swollen and luminous, flooding the dying landscape with light that seems almost accusatory in its brightness. You might be wondering why this matters, why you should care about orbital mechanics and ancient superstitions and the moon's slow escape from Earth's gravitational embrace. Here's why. Because we are not separate from the cosmos. Every atom in your body was forged in the nuclear furnace of a dying star. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was synthesized through stellar nucleosynthesis billions of years before you were born. You are literally made of stardust, as Carl Sagan so beautifully stated. But if you're made of stardust, then you're subject to the same forces that govern stars. The same gravitational waves that ripple across the universe from colliding black holes pass through your body every second of every day. The same electromagnetic radiation that fills the cosmic microwave background, the afterglow of the Big Bang itself, penetrates your cells. You are not observing the universe from some privileged position outside of it. You are the universe observing itself, and when the moon draws near, when its gravity tugs at the water in your cells, because your body is roughly 60% water, the same percentage that covers the Earth's surface, something changes. Something responds. Ancient humans knew this instinctively. Modern humans have forgotten. There's a theory in astrobiology, one that doesn't get discussed much in mainstream scientific discourse because it borders on the unfalsifiable and therefore the unscientific. It suggests that the moon is not just Earth's satellite, but its regulator, a cosmic guardian that has made complex life possible through its stabilizing influence on our planet's axial tilt. Without the moon, Earth would wobble chaotically on its axis like a spinning top losing momentum. The poles would drift. Climate zones would shift unpredictably. Seasons would become so extreme and so unpredictable that complex ecosystems could never establish themselves. Intelligence would never evolve because survival would require constant adaptation to chaotic environmental swings rather than the slow, stable progression that allows for evolutionary refinement. In this view, the moon is not merely a dead rock, but a necessary condition for consciousness itself. And if the moon is necessary for consciousness, then what happens as it recedes? What happens when this stabilizing influence gradually diminishes over the next billion years? What happens to the life, to the consciousness, that the moon midwifed into existence? The Super Beaver Moon is drawing closer tonight, not because it wants to, but because orbital mechanics demand it. The laws of physics, as far as we understand them, require this approach. Kepler's laws of planetary motion, Newton's law of universal gravitation, Einstein's general relativity, they all predict with extraordinary precision when and how close the moon will come. There is no mystery here. There is no warning. It's just math, just gravity, just the inevitable unfolding of natural law. Except that we don't fully understand gravity. We can describe what it does with remarkable accuracy, but we still don't know what it is. We don't know why mass curves space-time or what space-time actually is beyond a mathematical construct that makes our equations work. We don't know if gravity is quantum, if it has particles called gravitons, if it operates the same way at cosmic scales as it does in your living room. Gravity remains, after centuries of study, profoundly mysterious. So when we say the moon's approach is just gravity, we're really saying we don't know why it happens, only that it does. And in that gap between description and understanding, there's room for something else. Something that might explain why human beings across all cultures and all times have looked at the full moon with a mixture of awe and dread. The word lunacy comes from lunar, relating to the moon. The word lunatic shares the same root. For thousands of years, human societies have associated the full moon with madness, with transformation, with the unleashing of hidden aspects of the self. Werewolf legends span continents. Police reports show increased emergency calls during full moons. Hospital emergency rooms staff up in anticipation of higher admission rates. Psychiatric wards brace for more violent episodes. Scientists dismiss this as confirmation bias, as pattern-seeking brains finding connections that don't exist. Studies show no statistical correlation between moon phases and human behavior. But the belief persists, the anxiety persists, and perhaps that persistence itself is the evidence. Perhaps the warning is not written in tidal charts or gravitational equations, but in the collective unconscious of our species. A deep, pre-rational understanding that when the moon comes close, when its light floods the darkness, something fundamental changes. So tonight, when you look up at the Super Beaver Moon hanging bloated and bright against the November sky, ask yourself, what am I really seeing? A natural satellite following its appointed rounds? Or something more? A message written in orbital mechanics? A warning encoded in gravitational poetry? The universe is under no obligation to make sense to you. It does not owe you explanations. It does not care if you understand its language, but it speaks nonetheless, in colliding galaxies and dying stars, in quantum fluctuations and cosmic radiation, in the slow drift of continents and the patient recession of the moon. And sometimes, just sometimes, it speaks loudly, clearly, in phenomena so obvious that even we, with our limited senses and our prideful intellects, cannot help but notice. The moon is closer tonight than it will be for months. It's larger, brighter, more present. And perhaps, just perhaps, that presence is not coincidental. Perhaps the cosmos is trying to tell us something we desperately need to hear. The question is, are we listening? Or are we too distracted by our screens, our theories, our comfortable certainties to notice that the universe is speaking? That it's been speaking all along? That the Super Beaver Moon is not just a celestial event, but a cosmic conversation we've been ignoring for far too long? Let's start with something you think you know. The moon orbits Earth in an ellipse, completing one revolution roughly every 27 days. This is textbook astronomy, elementary school science, the kind of fact that feels as solid and unquestionable as the ground beneath your feet. Except the ground beneath your feet, as we've already established, rises and falls 12 inches during a supermoon. So perhaps we should be more careful about what we label as solid truth. The moon's orbit is not simply an ellipse. It's a constantly shifting, perpetually adjusting pathway through space that's influenced by the sun's gravity, by Jupiter's distant pull, by the other planets' collective mass, by the asymmetrical distribution of mass within Earth itself, by solar wind pressure, by tidal friction, and by forces we're only beginning to understand. When astronomers calculate the moon's position, they're not solving a simple two-body problem. They're wrestling with an n-body chaos where n includes factors we can barely measure, and some we probably haven't even identified yet. The moon's path through space is less like a railroad track and more like a river finding its way through constantly shifting terrain, predictable in the short term, profoundly uncertain over geological timescales. Here's where it gets strange. The moon shouldn't exist, not the way it does, not with its size relative to Earth. In our solar system, moons are typically tiny compared to their parent planets. Jupiter's moons, Saturn's moons, even Mars's potato-shaped satellites are all proportionally minuscule. But Earth's moon is roughly 1/4 the diameter of Earth itself. If you could see our planet-moon system from deep space, you wouldn't see a planet with a satellite. You'd see a binary system. Two worlds locked in a gravitational dance that's more partnership than hierarchy. This is unusual. This is, in fact, so unusual that many planetary scientists don't consider Earth-Moon a planet-satellite system at all, but rather a double planet. And double planets require special circumstances to form. Violent circumstances, catastrophic circumstances. The kind of circumstances that should have destroyed the possibility of life ever arising on Earth's surface. 4.5 billion years ago, the universe was already ancient. The Big Bang had occurred more than 9 billion years earlier. Generations of stars had already lived and died, seeding the cosmos with heavy elements. The Milky Way galaxy was well established, its spiral arms turning with the slow inevitability of a cosmic whirlpool. And in one unremarkable corner of this galaxy, around one mediocre yellow dwarf star, a planetary system was coalescing from the debris disk that surrounded the young sun. Dust grains stuck together. Pebbles became boulders. Boulders became planetesimals. Planetesimals became protoplanets. It was a violent nursery where impacts were not aberrations, but the fundamental mechanism of planetary growth. Everything was colliding with everything else in a demolition derby that lasted millions of years. And then, in one particular collision, one particular moment of cosmic violence, Theia struck Earth. Imagine it. Not in the sanitized, computer-animated way you've seen in documentaries, but really imagine it. A world the size of Mars, traveling at roughly 15,000 miles per hour, approaches the young Earth. For a brief moment, if there were eyes to see it, two planets share the same sky. The gravity between them is already tearing at each other's surfaces, raising mountain-sized tidal bulges, generating enough friction to melt rock. And then contact. The impact releases energy equivalent to billions of nuclear weapons detonating simultaneously. The Earth's crust vaporizes. The mantle becomes an ocean of molten rock, thousands of miles deep. Theia's iron core plunges toward Earth's core, merging the two in a process that takes hours. Theia's mantle, superheated, vaporized, turned into a plasma hotter than the surface of the sun, explodes outward, mixing with Earth's vaporized crust. Some of it escapes Earth's gravity entirely and is lost to space. Some of it rains back down onto the Earth's surface in drops of molten metal and stone. And some of it, a significant portion, enters orbit. Within a year, maybe less, this orbiting debris coalesces into the Moon. This is the giant impact hypothesis, and it's the best explanation we have for the Moon's existence. It explains the Moon's size, its composition, the absence of a significant iron core, the isotopic similarities between Earth and Moon rocks. It's elegant. It's well supported by evidence. It's almost certainly true. But here's the problem. It shouldn't have worked. Computer simulations of the Theia impact show that most debris from such a collision should either fall back to Earth or escape into space entirely. Only a small percentage should enter stable orbit. And yet the Moon contains nearly 2% of Earth's total mass. That's an enormous amount of material. Run the simulation 1,000 times with slightly different initial conditions, and in most cases, you don't get a moon at all. You get either a sterile, superheated Earth with no satellite, or you get a ring system that eventually decays. The fact that we're here, that there's a moon in our sky, that complex life had the stable conditions necessary to evolve into consciousness capable of asking these questions, it's improbable. Not impossible, but improbable enough that you have to wonder if probability is the right framework for understanding cosmic history. The universe, we're told, operates on natural law, predictable, mechanistic. Given the initial conditions and the laws of physics, everything that follows is determined, or at least probabilistic in ways we can calculate. The Moon's position tonight was determined 4.5 billion years ago when Theia's trajectory intersected Earth's orbital path. Your existence was encoded in that collision, in the precise angle of impact, in the exact velocity, in the specific distribution of debris. Change any one variable by a fraction of a percent, and you're not here. Earth might not even be here, not as a habitable world. And yet here we are. The moon hangs in the sky, closer than usual tonight, and you're alive to see it. Coincidence? Perhaps. But the universe is under no obligation to be coincidental. It can be intentional, meaningful, communicative, or it can be something else entirely. Something we don't have words for yet because our language evolved to describe savanna survival, not cosmic architecture. If the universe has no edge, then where does it begin? If time itself was born in the Big Bang, what does before even mean? And if the moon's existence is statistically improbable, yet observably real, then perhaps probability is not the language the cosmos speaks. Perhaps there's something else operating beneath the equations, something that guides matter and energy not randomly, but purposefully. Something that creates moons like ours not by chance, but by design. Something that positions them in orbits that slowly decay, that brings them close on certain nights as if to remind us, you are not separate from this. You are not observers. You are participants in a cosmic drama whose script was written before time itself learned to flow. The moon is slowing down time. Not metaphorically, not poetically, literally. Every century, Earth's rotation decelerates by roughly 1.7 milliseconds because of tidal friction caused by the moon's gravitational pull. The oceans bulge toward the moon, creating tidal bulges that drag against Earth's surface as our planet rotates. This friction acts like a brake, gradually slowing Earth's spin. 400 million years ago, during the Devonian period when the first forests were spreading across the continents, a day lasted only 22 hours. Go back further, to the Cambrian explosion when complex life was just beginning its evolutionary experiment, and a day was barely 21 hours long. Rewind to the moon's formation, and Earth was spinning so rapidly that a day lasted perhaps 4 to 6 hours, meaning a year contained more than 1,000 days. The moon, through nothing more than its gravitational presence, has been stealing Earth's rotational energy for billions of years, converting our planet's spin into heat through tidal friction and simultaneously pushing itself into a higher orbit. This is why the moon recedes. This is why it drifts away at 1.5 inches per year. It's stealing time itself, converting Earth's rotation into orbital distance, and we've barely noticed because the change is so gradual that it's invisible within a human lifetime. But here's the implication that should unsettle you. If the moon controls the length of our days, if it regulates the passage of time on Earth's surface, then what is time? Is it a fundamental property of the universe, or is it something that can be manipulated by mass and gravity? Einstein told us that time is relative, that it flows at different rates depending on velocity and gravitational fields. A clock at sea level ticks slower than a clock on a mountaintop. Time near a black hole's event horizon slows to a crawl compared to time in deep space. But if time is not absolute, if it can be stretched and compressed and stolen by gravitational interactions, then perhaps time is not flowing at all. Perhaps time is like a film reel where every frame already exists, and what we experience as the passage of time is merely our consciousness moving through pre-existing moments. In this view, the past still exists. The future already exists. Your birth and your death are equally real, equally present, separated not by time, but by position. Along a fourth-dimensional structure, we can only perceive one moment at a time. This is the block universe theory, and it's not science fiction. It emerges naturally from Einstein's equations. Space-time, according to general relativity, is a four-dimensional manifold where time is just another dimension, no fundamentally different from length, width, and height. If you could step outside space-time and view it from a transcendent perspective, the view that physicists call the God's eye view, you would see all of history laid out simultaneously. The dinosaurs would still be walking the earth. Your childhood self would still be learning to read. Your future self would already be experiencing whatever comes next. Nothing ever truly happens. Everything simply is, eternally present in the block universe. And if this is true, then the moon's approach tonight, this Super Beaver Moon that seems so immediate, so now, has always been approaching. It approached 4.5 billion years ago when Theia struck Earth. It approaches now as you read these words. It will approach again next November and the November after that, unto the end of time. All of these approaches exist simultaneously in the eternal present of space-time, which means the warning, if there is a warning, is not happening now. It has always been happening. It will always be happening. Time is the illusion. Causality is the illusion. The moon has already delivered its message, and we're still trying to decode it across billions of years that don't actually separate us from the moment of impact. But there's a problem with the block universe, a profound problem that threatens the entire framework: quantum mechanics. At the quantum scale, particles don't have definite properties until they're observed. An electron doesn't have a specific position or momentum until you measure it. Before measurement, it exists in a superposition of all possible states simultaneously, described by a probability wave function. Schrödinger's famous cat is both alive and dead until you open the box and collapse the wave function through observation. This is not a thought experiment or a metaphor. It's how reality actually behaves at the smallest scales. Experiments confirm it over and over again. The double-slit experiment shows that a single photon can pass through two slits simultaneously and interfere with itself, creating an interference pattern, unless you observe which slit it passes through, in which case the interference pattern disappears and the photon behaves like a particle that went through only one slit. The act of observation changes reality. Consciousness, or at least measurement, plays a fundamental role in determining what exists, and this creates an irreconcilable conflict with the block universe. If the future already exists in Einstein's space-time, then quantum particles in the future already have definite states. But quantum mechanics says they don't have definite states until observed. These two pillars of modern physics, general relativity and quantum mechanics, give us contradictory pictures of reality. One says time is an illusion and everything already exists. The other says the future is genuinely undetermined, that reality is created moment by moment through observation and measurement. Both theories are experimentally confirmed to extraordinary precision. Both cannot be fully true, and we have no idea how to reconcile them. This is where the moon becomes more than a satellite. It becomes a laboratory for testing the deepest questions about reality. The moon is massive enough that general relativity's description of gravity applies. Space-time curves around it. Time dilates near its surface. Its orbit follows geodesics through curved space-time. But the moon is also made of atoms, of quarks and electrons, of quantum fields. At some scale, quantum effects must become relevant. But where? When does a collection of quantum particles become large enough that quantum superposition collapses into classical definiteness? The moon is neither microscopic nor cosmic. It occupies a middle ground where both quantum mechanics and general relativity should apply. So what happens to the moon when no one is observing it? Is it really there, with a definite position and momentum? Or is it, like Schrödinger's cat, in a superposition of all possible positions until someone looks up and collapses the wave function? Absurd, you say. The moon is obviously always there, except obviously is not a scientific argument. Quantum mechanics makes no exceptions for objects we think should behave classically. The equations don't care about your intuition. And here's the truly unsettling part. We have no experimental way to test this. We can't stop observing the moon. We can't isolate it from measurement. There's always light bouncing off it, always gravitational interactions, always some form of quantum entanglement with the environment. The moon is never truly unobserved, which means we can never know if it's really there when we're not looking. The universe might be constantly creating the moon, moment by moment, in response to our observations. Or the moon might exist independently, indifferent to our gaze. Both scenarios are consistent with everything we've observed. Both are equally valid interpretations of quantum mechanics, and we have no way to determine which is true. The warning of the Super Beaver Moon might not be about orbital mechanics or tidal forces. It might be about this, about the realization that we don't know if reality exists when we're not looking at it. That consciousness might not be observing the universe, but actively creating it through observation. That the cosmos might need us just as much as we need it. That the moon's approach is not a mechanical event, but an invitation to witness, to participate, to collapse the wave function of cosmic possibility into the single reality where humans exist to ask these impossible questions. So, let's stop for a moment. Let's pull back from the equations and the theories and the cosmic timescales and talk about what this means for you. Not for humanity in the abstract, not for some future civilization that might decode these mysteries. For you, right now, reading these words while the Super Beaver Moon hangs somewhere above you in the November sky, whether you can see it or not. If the block universe is real, then everything you've ever done still exists. Your first kiss still exists, frozen in space-time like a fly in amber. Your worst mistake still exists. Your greatest triumph still exists. Your death still exists, already written into the fabric of space-time, waiting for your consciousness to arrive at that particular coordinate. You think you're moving forward through time, making choices, creating your future, but in the block universe, you're not creating anything. You're discovering. You're reading a book that's already written, experiencing a story whose ending was determined before you were born, before the Earth was born, before the universe cooled enough for matter to exist. Free will becomes a beautiful illusion, a trick of consciousness that makes you feel like an author when you're really just a reader experiencing your own life one moment at a time. And if quantum mechanics is right, if reality is genuinely undetermined until observed, then you're not reading a pre-written story. You're collapsing probability waves with every moment of consciousness, actualizing one specific timeline out of infinite quantum possibilities. Every choice you make splits the universe. Every decision creates a new branch of reality where the other option also happened. There's a version of you who made every possible choice at every possible moment. A version who became a doctor. A version who died in childhood. A version who never existed because your parents never met. A version who exists in a universe where the moon never formed, where Earth was struck by Theia at a slightly different angle and became a lifeless, molten hell. All of these versions are equally real, equally you, existing in parallel quantum branches that can never communicate, never verify each other's existence. You are not one person living one life. You are an infinite multitude of persons living every possible life simultaneously across the quantum multiverse. And the version of you reading these words right now, you're just one thread in an infinite tapestry, with no way of knowing if you're the main thread or just one of countless copies. Do you feel it yet? The vertigo? The sense that the ground is not as solid as you thought, that reality itself is less stable than the comfortable lies we tell ourselves? This is what the ancient mystics called ego death, the dissolution of the self when confronted with the infinite. This is what Pascal meant when he said the eternal silence of infinite spaces terrifies him. The universe is not just large. Large is a word that applies to mountains and oceans and planets. The observable universe is 93 billion light-years in diameter. Light traveling at 186,000 miles per second would take 93 billion years to cross it. Except the universe is only 13.8 billion years old. So how can light have traveled 93 billion light-years? Because space itself expanded faster than light during the inflationary epoch, the first fraction of a second after the Big Bang, when the universe doubled in size at least 90 times in less time than it takes a photon to cross an atomic nucleus. The observable universe is a bubble of causality beyond which we can never see, never travel, never communicate, because the space between us and the edge is expanding faster than light can cross it. And beyond that bubble, perhaps infinite space filled with infinite galaxies, perhaps other bubble universes with different physical constants, different laws of physics, different dimensions, perhaps nothing at all. Not empty space, but the absence of space itself. You cannot imagine this. Your brain, evolved to track predators on the African savanna, cannot process scales this vast. You can say the words 93 billion light-years, but you cannot feel them. You cannot internalize them. The universe is not just incomprehensibly large, it's categorically beyond comprehension. And you are made of atoms that are 99% empty space. If an atom were the size of a football stadium, the nucleus would be a marble at the 50-yard line, and the electrons would be pinpricks of probability orbiting somewhere in the parking lot. The solid matter you think of as your body is mostly nothing, held together by electromagnetic forces that prevent the electron clouds of your atoms from overlapping with the electron clouds of the chair you're sitting in. You are not solid. You are a pattern of forces, a temporary configuration of quantum fields, a wave function that happens to be conscious. And that consciousness, that sense of being you, of having thoughts and feelings and memories, emerges from 86 billion neurons firing in patterns we don't understand, creating an experience of selfhood that might be the universe's only way of knowing itself. Carl Sagan said we are a way for the cosmos to know itself. But what if that's not poetic metaphor? What if consciousness is not an accident, not a fortunate byproduct of evolution, but the universe's purpose? What if the Big Bang happened specifically so that 13.8 billion years later, conscious beings could emerge and collapse quantum wave functions and actualize one specific reality out of infinite quantum possibility? What if you are not witnessing the universe, but creating it through the act of observation? What if the Super Beaver Moon is only real because you're looking at it, and when you turn away, it dissolves back into probability until someone else looks up? This is cosmic horror. Not the gothic horror of vampires and demons, but the existential horror of realizing You don't know what reality is. You don't know if you're real. You don't know if anything is real beyond your immediate observation. You don't know if you have free will or if you're following a script written in the initial conditions of the Big Bang. You don't know if you're one consciousness or infinite consciousnesses across the multiverse. You don't know if time is real or an illusion. You don't know if the universe is dead matter following mindless laws or a living consciousness of which you are a fragment. And the universe offers no answers. It simply presents phenomena, supermoons and tidal forces and quantum superpositions, and leaves you to interpret them with a brain that evolved for survival, not comprehension. The moon is closer tonight. That's a fact. What it means is up to you. And that, perhaps, is the most terrifying realization of all. Here's what they don't tell you in the astronomy textbooks. What gets whispered about in theoretical physics conferences after the formal presentations end and the wine begins to flow. The moon's recession is not random. It's not simply a consequence of tidal friction and angular momentum conservation. Those are the mechanisms, yes, but mechanisms are not purposes. A clock's gears explain how it tells time, but not why anyone built it. And the moon, this improbable, oversized satellite that shouldn't exist, that emerged from cosmic violence with mathematical precision, that stabilized Earth's axis and regulated our climate and created the conditions for complex life to evolve consciousness. The moon is leaving. It has been leaving for 4.5 billion years. In another billion years, perhaps less, it will be too far away to stabilize Earth's axial tilt. The poles will begin to wander. Climate zones will shift. The oceans that the moon's gravity currently controls will slosh chaotically. And the total solar eclipses that inspired ancient civilizations to develop astronomy, that revealed the sun's corona and led to breakthrough discoveries about solar physics, those will end. The moon will appear too small to cover the sun's disk completely. The perfect alignment, that 400-to-1 ratio that seems too precise to be coincidence, will be broken. The message, if it is a message, will become unreadable, unless we're not supposed to read it forever. Unless we're supposed to read it now. What if the moon's entire existence has been building toward this moment? Not this particular November night, but this brief cosmic window when intelligent observers exist to witness the perfect eclipses, when consciousness has evolved to the point of asking these questions, when technology has advanced enough to detect gravitational waves and quantum entanglement and the cosmic microwave background. What if the universe is not infinite and eternal but finite and purposeful, and everything that has happened? The Big Bang, the formation of galaxies, the synthesis of heavy elements in dying stars, the collision of Theia with Earth, the slow recession of the moon. What if all of it was necessary steps in a cosmic algorithm designed to produce this? Consciousness, capable of collapsing quantum wave functions and actualizing one specific timeline out of infinite possibility. In the quantum multiverse, every possible universe exists. Universes where the fundamental constants are different and atoms cannot form. Universes where stars never ignite. Universes where planets never coalesce. Universes where Theia missed Earth entirely. Universes where the moon formed but was too small or too large or too close or too far. Infinite variations, infinite failures. And then this one. This specific timeline where everything went right. Where the moon is exactly the right size at exactly the right distance for exactly the right duration to create exactly the conditions necessary for you to be here now, reading these words while the Super Beaver Moon hangs in the November sky. This is the anthropic principle taken to its logical extreme. We don't observe a universe that's friendly to life because we got lucky. We observe this universe because it's the only one that produced observers. All the other quantum branches exist, but they're dark, silent, unobserved. Only in this branch, this razor-thin probability where everything aligned, does consciousness emerge to collapse the wave function and make reality real. And if observation creates reality, if consciousness is what actualizes the universe from quantum possibility into classical existence, then the moon is not just a satellite. It's a catalyst, a cosmic trigger designed to create the conditions for consciousness so that consciousness can observe the universe, so that the universe can exist. The moon created you so that you could observe the moon, so that the moon could be real. Causality eating its own tail. A strange loop where effect precedes cause, where the future determines the past, where the universe bootstraps itself into existence through the consciousness it will eventually produce. But here's the final twist. The revelation that should make your skin crawl with something between terror and ecstasy. If this is true, then the moon's recession is not a tragedy. It's a countdown. The moon has been moving away from Earth since the moment it formed because its job is almost done. Think about it. The moon stabilized Earth's climate long enough for life to evolve. It created tides that may have been necessary for life to transition from ocean to land. It lit the night for early humans, providing just enough illumination for nocturnal activity without overwhelming the stars. It inspired mythology and mathematics and the first astronomical observations. It gave us a laboratory for testing physics, a tawdry world close enough to visit but far enough to require technological advancement. It provided the perfect solar eclipses that revealed the sun's corona and confirmed Einstein's general relativity. And now, in the 21st century, as humanity develops quantum computers and gravitational wave detectors and begins to seriously grapple with the nature of consciousness and reality, the moon is still here, still close enough to create supermoons that draw our attention skyward. Still present for a few more million years before it recedes beyond relevance. Almost as if it's waiting, watching, giving us one last chance to understand the message before it's gone forever. And what is the message? Perhaps this: you are not an accident. Consciousness is not an accident. The universe is not a random arrangement of particles, but a self-organizing system that creates the conditions for its own observation. The moon is not warning you of danger. It's confirming your purpose. You exist to observe, to witness, to collapse quantum probability into classical reality. Every time you look up at the night sky, you're not seeing the universe, you're creating it. Every observation actualizes one timeline out of infinite quantum possibility. And somewhere, in the infinite branches of the multiverse, another version of you is reading these words right now. And another, and another. An infinite cascade of consciousnesses, each collapsing their own wave function, each creating their own reality, each looking up at their own Super Beaver Moon and wondering, is this a warning? Or an invitation? The answer like everything else in quantum mechanics, depends on the observer. The cosmos is speaking. It's been speaking for 13.8 billion years. The question is not whether you're listening. The question is, are you ready to hear what it's saying? Tonight, the Super Beaver Moon hangs closer than it has in years. You know the science now. You understand the orbital mechanics, the quantum paradoxes, the existential implications. But understanding is not the same as knowing. The ancients looked up at the full moon and felt something we've tried to rationalize away. A sense that the cosmos is not indifferent. That consciousness and universe are entangled in ways we're only beginning to glimpse. So go outside, look up, and ask yourself, is that satellite you're seeing? Or are you collapsing a wave function? Are you observing the universe, or is the universe observing itself through you? The moon offers no answers, only light, only gravity, only the ancient invitation to witness. Perhaps that's enough. Perhaps that's everything. The cosmos may be infinite and eternal, but maybe, just maybe, so are you.